In number 22, a gas occupies a volume of 211 centimeter cube at 18 degrees Celsius. What volume will it occupy at 28 degrees Celsius? In this question, we have that volume is changing with temperature. And to solve this, we need to apply Charles' law. The law states that at constant pressure, the volume of a fixed mass of gas is directly proportional to the absolute temperature. Mathematically, we have V1 over T1 equals V2 over T2. And the absolute temperature here implies that we are going to be using temperature in Kelvin and not in degrees Celsius. So we need to convert the values. T1 is 18 degrees Celsius. You add 273. You will have the absolute temperature giving 291 Kelvin. We also have T2, which is 28 plus 273, giving 301 Kelvin. And from here, we can substitute the values. We have V1 as 211. So 211 all over T1, which is 291, should be equal to V2, what we are looking for, divided by T2, which is 301. So we have that V2 should be equal to, you cross multiply, you have 211 times 301, and we divide by 291, which gives 218.3 approximately, corresponding to option A. Questions 23 to 24 concern the following equation. We have propanoic acid reacting with ethanol in the presence of acid solution to give propyl ethanoate and water. The first question, what name is usually given to this reaction? This is esterification, the reaction between a carboxylic acid and an alcohol to give an ester and water only. 24. What is the role of H+ ions in the reaction? Their role is catalytic. They catalyze the forward reaction. In number 25, catalytic oxidation or reduction is used in the manufacture of the following heavy chemicals, except sodium hydroxide, ammonia, nitric acid, and sulfurous acid. They are manufactured using catalytic oxidation. In number 26, a solution of a substance gives a blue gelatinous precipitate with sodium hydroxide solution. The substance could be the blue precipitate suggests the presence of copper 2 ions. So that should correspond to A, copper 2 sulfate. Questions 27 to 28 concern the following equation. We have hydrochloric acid reacting with sodium thiosulfate to give sodium chloride, sulfur, sulfur dioxide, and water. 27. What will you observe when dilute hydrochloric acid is added to a solution of sodium thiosulfate? The observation comes at the level of the products. We have A clear solution is formed. B, a yellowish gas is evolved. C, a yellow precipitate is formed. D, a salt is formed. The most prominent observation is the deposition of sulfur. So you would see a yellow deposit because sulfur is a yellow solid. In number 28, what will happen when the concentration of hydrochloric acid is increased? So hydrochloric acid being one of the reactants, if you increase the concentration of hydrochloric acid, then the equilibrium would shift to the right so as to annul the effect that has been produced according to Le Chatelier's principle. So we expect equilibrium position to shift to the right, corresponding to option A. Questions 29 to 31. Instructions. For each of the questions below, one or more of the responses numbered 1 to 4 are correct. Decide which of the responses is or are correct, then choose A if 1, 2, and 3 are correct, B if 1 and 3 are correct, C if 2 and 4 are correct, D if 4 only is correct. The instructions are summarized as A, if 1, 2, and 3 only. B, if 1 and 3 only. C, if 2 and 4 only. D, 4 only. In number 29, which of the following is a characteristic property of transition elements? So the property that is common to transition elements only. 1. Good conductor of heat and electricity. No. This is common to all metals. Transition elements are metals. They are not the only metals. We also have groups 1, 2, and to a certain extent group 3, which are metals. So 1 is not correct. They form compounds with variable valencies. Yes, that is one of their characteristics. They react with dilute acids evolving hydrogen. No, this characteristic is common to most metals. 4. Solutions of their compounds are colored. Yes. So we have 2 and 4 only that are correct. So the correct option in this question is C. In number 30, select reactions which are common to alcohols. 1. They evolve white fumes with PCl5. Yes, this is their characteristic reaction which is used as a test for alcohols. 2. They react with organic acids to produce esters. Yes, this reaction is also common to alcohols. 3. They react with sodium evolving hydrogen gas. Yes, that is true. 4. They liberate carbon dioxide from carbonates. No. So we have 1, 2, and 3 that are correct, and that corresponds to option A. In number 31, when carbon burns in excess air, 1. An acidic oxide is formed. Yes, carbon burning in excess air usually gives carbon dioxide, and carbon dioxide is an acidic gas. 2. A neutral gas is formed. No, carbon dioxide is acidic. 3. A gas is produced which turns lime water milky. Yes, that is the test for carbon dioxide, which is produced due to burning of carbon in excess air. 4. A basic oxide is formed. No. So we have 1 and 3 only. So we have B as the correct option. In number 32, when ethane is mixed with bromine water, A, it slowly dechorizes it. B, a substitution reaction occurs. C, bromoethane is produced. D, no reaction occurs. So we have D as the correct option because bromine water actually is used as a test for unsaturation. Ethane, being a saturated hydrocarbon, has no effect on bromine water. In number 33, the reagent used to test for the presence of sulfate ions in the laboratory is acidified barium chloride. C. When you react acidified barium chloride with sulfate ions, you have a white precipitate of barium sulfate, which usually is insoluble in excess acid. In number 24, proteins are prepared from carbohydrates, glucose, amino acids, fats. Actually, amino acids are the building blocks of proteins. In number 35, why is it preferable to use copper than iron in making electric cables? A. Copper has a high melting point. No. Copper is heavier than iron. No. Iron rusts easily when exposed to air. D. Copper is a good conductor of electricity. So we have C. Iron rusts easily when exposed to air. So copper is preferred. In addition, both of them are good conductors of electricity anyway. But copper is usually preferred because it cannot undergo corrosion. Because it's resistant to corrosion or rusting, and also the fact that it is light. You can use it in overhead cables, for instance. In number 36, a student got stung by bees on campus. Sodium hydrogen carbonate was used in treating this bee sting. What chemical substance is found in a bee sting? The fact that sodium hydrogen carbonate was used in treating the bee sting, we expect that the bee sting should be acidic because sodium hydrogen carbonate is a base. So this treatment of the stink usually has to do with neutralization, reaction, and so in all the options, we only have B, formic acid. That can be the only option. In number 37, which one of the following procedures is most convenient and safe for the titration of sulfuric acid with sodium hydroxide? A. Run the acid from the burette into a conical flask containing the base and phenolphthalein. B. Run the base from burette into a conical flask containing the acid and phenolphthalein. C. Pipette the base. D. Run the base and the acid from the burette into a conical flask containing the phenolphthalein. Usually the safest way is A. Running the acid from the burette into the conical flask containing the base and the indicator is usually the safest way of doing titration. In number 38, consider the reaction barium hydroxide plus sulfuric acid to give barium chloride plus water. Calculate the concentration of barium hydroxide if 20 cm³ of barium hydroxide solution is neutralized by 30 cm³ of 0.1 molar hydrochloric acid. We have a neutralization reaction, and to do the calculation, we have the formula molarity of acid times volume of acid all over molarity of base times volume of base, being equal to the mole ratios. So the moles of the acid over the moles of the base should be equal to the moles of the acid in the balance equation over the moles of the base. So for molarity of acid, it is given as 0.1 molar, so 0.1 times the volume of acid, which is 30 cm³. You divide it by the molarity of base. Molarity of base, that's what we are looking for, times the volume of base, which is 20 cm³. Barium hydroxide, the base, the volume is given as 20 cm³. That should be equal to the number of moles of the acid in the balance equation, which is 2. So 2 all over the number of moles of the base, the balance equation, which is supposed to be 1. So we have 1. Then from there we cross multiply. We're going to have 0.1 times 30. That would give us 3 times 1 should be equal to 2 times molarity of base times 20. And so molarity of base will be equal to 3 times 1, which is 3, divided by 2 times 20, which is 40. And this gives 0.075 molar, corresponding to option B.